The event is organized by Knowledge and Technology Transfer Offices of University of Maribor and University of Ljubljana in collaboration with our industry partners and supporters from the innovation community. The main partner of the event is Novartis in Slovenia. Also, this festival would not have been possible without the support of the Republic of Slovenia and the European Union under the European Regional Development Fund. In this session, we will give a snapshot of competencies, innovative projects, and good collaborative practices in the field of data science and business intelligence. Each speaker will have a 3-minute long presentation, following 3 minutes for questions and comments. I'm happy to present our moderator, Mr. Mitja Trampuš. He is the president of the AI for SI initiative, which operates within the Association for Information Technology and Telecommunications at the Chamber of Commerce and Industry. The main task of the AI for SI initiative is to accelerate the use of artificial intelligence in the economy and above all to make it usable. Mitja is also the director of CreaPro, which for many years has been helping to introduce artificial intelligence in various business applications. Enjoy, and now invite Mitja. Mitja, please, the screen is yours. Thank you.
Thank you, Matjaž, for your introduction. Welcome all participants. Today it's going to be this 1-hour session is going to be quite interesting. We have 9 speakers from this domain. I think it's important to start right away. I would like to introduce Aida Kamišalić-Latifić. She's assistant professor, University of Maribor, Faculty of Electrical Engineering and Computer Science. She's going to present advanced data technologies empowering society transformation. Aida, the stage is yours.
Yes, thank you very much. Did I share, do you see my slides?
Yep.
Yes? Okay, thank you very much. I will try to keep with the time slot. So today I will present just 3 of our projects that we were working on in recent years. So the first one is collaboration with the Medica Apps company, where they are developing and implementing a system for data analysis from the Fly Sentinel system, which is a monitoring technology for controlling vital human functions and parameters, as well as prevention of potential risk situation in aviation. So we are trying to analyze the data from this system to detect the fatigue, and the pilot fatigue could be significantly improved if we adequately adjust environmental and physiological parameters. Another project that we were working on was actually collaboration with the University Medical Center Maribor, where we tried to support clinical decision-making processes. So here we try to predict the comorbidities occurrence or identify the most effective treatment procedures, such as to identify the drugs that have shown to be most effective. We are continuously working in this field, and one of our research papers, which was published in 2019, was selected among 3 best papers published in that year in the field of decision support, and it was selected by the International Medical Informatics Association. So we are trying to actually let's say use this research knowledge and transfer it to the practice. And the third project that I would like to present is also the collaboration with a company, with ECTA. We developed a blockchain and artificial intelligence based platform for global employability, which was aimed at solving employability issues, to offer equal employment opportunities for job seekers. So the automated recruitment process and job searching was supported by artificial intelligence, and the immutability of data and data integrity was enabled by blockchain technology. I hope I was not too long. I will finish with it here, and if there are any questions, I will be glad to answer.
Thank you, Aida. That was really quick on time. Excellent.
I tried to.
So we have some time for questions. I would like to invite all the participants to also ask some questions. You can type the questions in the chat box in Zoom. So we will try to answer them right now, or we have also some time at the end of all the presentations. Actually, there are 10 of them. So if there are any questions, I have one question for you, Aida. So it's definitely, did you detect some patterns, some specific patterns that especially attracted your attention or attention of the medical staff? This is in regards to the medical center in Maribor.
Yeah, yes, well, in this specific collaboration, maybe there was no something that would I will point out, but since I said that there are, we are continuously working on this in this field, there were projects that we were working using data from Spanish hospitals from Catalonia, and on those data we could see quite interesting patterns. Actually, we could see that that the results actually indicated that drug treatments were not were actually different from those recommended in the clinical practice guidelines. And those treatments have shown to be very effective. So this was really interesting that clinical practice guidelines were not actually recommending those treatments, but actually the professionals, medical staff, they were using those treatments. We were working on disease, chronic diseases such as diabetes, heart failure, hypertension, and we could see there different procedures, different treatments used than those provided by clinical practice guidelines. And that's why we, I like to say that this is something that we could use actually this pool of data as a source of knowledge, and get back what's actually functioning well and what's giving good results, and maybe use this then further on.
Thank you, because you presented 3 projects. I have one, it's my personal interest as well. For this medical app, where you detect the fatigue of the pilots, how you do that? Can you just briefly explain how this is possible?
Yeah, well, we are trying to detect here the stress. This is the first step. So we made a study to evaluate how good we are actually in predicting which human parameters actually mean that person is in a stress, and that we can differentiate between physical, for example, activity, which could lead to changes in measures of human parameters, and which doesn't mean that actually person is actually in a stress. This was the first step to detect the pilot fatigue, actually to detect, considering these stressful situations. We were developing machine learning algorithms with, let's say, heart rate based machine learning algorithms to analyze heart rate variability signal that we receive from this Fly Sentinel system.
Sensors. I hope you will save many lives in the future with this. Thank you. Thank you very much, Aida. Thank you. We'll maybe talk later, get back later to you and your projects. I would like now to introduce Slavko Žitnik. He's assistant professor of University of Ljubljana. Slavko is going to present development of a platform for fast and distributed text processing. Slavko, the stage is yours.
Thank you. So I will present community monitoring platform that we developed for the company Press Clipping in Maribor. So first, I may say what the company actually does. So they get media news for all the media in Slovenia daily, and they need to process this media and provide in which news articles their subscribers were mentioned. This is, let's say, the basic part they are doing. And apart from that, they also offer other services to partners, some additional analysis. So for example, in specific time frame, where in which media company was mentioned, what was their sentiment, how were their other partners mentioned, or other companies that doing the same business, and so on. And for them, we developed a platform like this. So on the left side here we see media. So they have contracts with traditional media and electronic media in Slovenia. And with this platform, they also added social networks to ingest data. This was their part, as they have crawlers and programs to fetch data. And in our part, we developed some analysis on top of this text. And in this text, we first need to identify for which subscribers the text is relevant to. And then additional analysis refer to, for example, extracting entities, recognizing relationships within them, recognizing sentiment on the top or topic of specific news text, and so on. After that, the data is stored in a data lake. We use a Solr search engine for that. And when data is stored, we enable analysis on the data lake. That means their analysts can provide additional analysis. For example, for specific time frame, they may be interested in which news articles CEO of a subscriber was mentioned, or whether a product that the company developed was accepted well in public or not, and things like that. So the tool is mostly used by their analytics, and also part of the project was related to public domain. So we offered like website for the public, where the public can get insight about societal groups, how they feel in Slovenia. So we somehow identified 5 societal groups, and for each of the societal group, we cluster media and identify their feeling. So let's say the elderly people might be happy, the students might have some problems, and so on. And a specific group can be further investigated and also seen in time. So someone is able to browse along this news. This website is still in development, but the other parts are already finished. So we hope that also this part will be published soon. And for the end, I would just like to present our team, which mainly consists of colleagues from the Faculty of Computer Science and Informatics in Ljubljana, and 2 colleagues that are coming also from Computer Science AIDA, and Dan Podjet, who took care of the societal challenges of this project, which are also important, because it's not important also just to develop some technologies, but also to be able to justify why these technologies are useful and who will use them. That would be from my side. If there are any questions, I would be happy to answer.
Thank you, Slavko. I'm inviting all participants also to write your questions in the chat box. Thank you for our presentation. I would have one question. It's related to the dimensions of how much content do you need to process daily, roughly?
Daily, probably around 100,000 news articles are processed from traditional and electronic media.
Okay, how did you find this company, Press Clipping? How did you start collaborating with them? What was the trigger? How did you find yourself?
There was interesting story, maybe. Nelly Blagus finished PhD at our faculty some time ago, and then she proposed a project from by some other company. And while she was working there, she was brainstorming with us where she could get some data from social media to process the data, to get some insight into the society. And then we were thinking, okay, who is doing some media monitoring in Slovenia and sending us daily news. So we just contacted Press Clipping, and after a year or two, after our talks, they reminded of us because they proposed their own project, and they invited us to collaborate with them.
That's a nice example of how this can really bear fruits. Excellent. I like these stories. Perfect. Thank you very much, Slavko.
Thank you.
It was very interesting. For the participants who joined a bit later, this is Unimind's event, Smart Future. This track is Data Science and Business Intelligence track. And I would like now to introduce Aida Pritnar. She's a co-worker of Slavko. She's a researcher at the Faculty of Computer and Information Science. And Aida will present combining soft and hard approaches for designing user-friendly solutions. Aida, the stage is yours.
Thank you. So today I would like to talk about why it's beneficial to combine data science with anthropology. Our case study was a smart building of the Faculty of Computer and Information Science, which records over 20,000 input-output signals. The aim of the project was to decrease energy consumption in the building. But because decreasing energy consumption is not a good motivating factor in public buildings, we decided to couple this goal with a goal of improving worker health and comfort. Because people care about their health, and we made this goal much more personal. An easy way to decrease energy consumption and increase health is to ventilate the rooms, and this is mainly achieved by opening the windows. To observe how air quality affects people's frequency of opening the windows, we installed an air quality sensor in certain rooms. The sensor was displayed next to the doors, and it showed a light which reflected whether the air was good. This was the green light, and if the air was bad, the light was red. So we collected a large amount of data in the project, which we analyzed with clustering, time series analysis, and by observing individual frequencies. With this, we realized that people mostly open windows in the afternoon, but they forget to open, in the morning, but they forget to open them in the afternoon, despite the air quality being very low. So we identified certain seasonal and behavioral patterns with data mining, but we still were missing the why and the how. What is the impetus for opening the windows? Why was the sensor effective in the beginning of the project, but not so much in the end? And how important is air quality to the research participants, and why they forget to open their windows? By employing ethnography, we realized how important the routine is. In the morning, people had a predefined set of steps that included opening the windows, but in the afternoon, they forgot about it. We also identified phases of adaptation to the air quality sensor, which ranged from great interest in the beginning to frustration in the middle and to ignoring the sensor in the end. People were frustrated with the sensor because the light didn't go green despite opening the windows. So people opened the windows, but it didn't reflect that. So the sensor didn't reflect the result. Only later, people realized that the sensor actually reflected the general air quality score, which included room temperature. So if the room temperature was low, the score would also be bad, and people opened the windows in the winter, so the air got cold, of course. But people were already so disillusioned with this sensor that they stopped using it. In summary, motivation is not enough for changing the behavior. Opportunity and clarity of steps is also important. This is why products and solutions need to enable people to change their behavior in a simple way. And a way to achieve this is by combining anthropology and data science, in my opinion, because data science helps us recognize relevant patterns of human behavior, and anthropology helps us explain them. With a combination of the two approaches, we can design better products that people will love to use. Thank you.
Thank you, Ida. This, I think it's a very interesting case. I think it can find a broad acceptance. It's useful for sure, should be. I would like to ask you a question again. I would like to invite all participants to ask some questions in the chat box, but a question from my side would be if you could tell us maybe some other examples of successful combination of anthropology and data science. I'm sure you know some.
Yes, so one was the project that Slavko already mentioned, the Centimeter, where we also employed anthropology, specifically focus groups, where we gathered potential end users and we asked them questions about the product that we presented. So together we were able to identify things that we took for granted as designers and developers, and people said, no, this is not obvious, you need to fix this. I don't know how to use this. So this was a really nice way of collaborating with the potential users and to refine the product to make it better.
Yeah.
So there's a question in the chat. Perhaps I can answer that.
Oh, thank you. Yes, we can. Let's check. In the meantime, if you can also maybe answer this question, this data science should be interdisciplinary. Why would we work with anthropologists and not other specialists? Why would you go with that?
So, of course, data science can work with a lot of different profiles. So a data scientist would recognize the patterns, and then you need, of course, a domain expert that would help explain it. And anthropologists are domain experts in human behavior and human habits and practices. But of course, it goes without saying that sociologists, even psychologists, cognitive scientists are also a very nice fit for data science.
Mm-hmm. Mm-hmm. There's a very interesting question from our participant. Have you been identifying personal behavior patterns and maybe design a feedback loop to invite people to open the window?
Yes, so we were monitoring 14 rooms and we identified specifics for each room. The feedback loop was, so one part of the feedback loop was the SET sensor, which showed the air quality with a light, and people responded fairly well to it. But also we designed so non-digital, so to speak, campaigns, which like analog campaigns, which were just simple posters that encouraged people to open the windows. When they entered the room, they saw the poster, and this should have reminded them to open the window. But of course, people also need to be motivated to make a change.
Always, as always. Which is your typical client profile? How would you say?
So for collaboration, okay, so probably this would be any company that develops a kind of end product for the users and that needs to identify how this product should look like, how should it be used, and how to optimize it for the people. Excellent.
Wish you a lot of success. Very interesting topic.
Thank you.
Thank you, Aida. I would like to introduce the next speaker. It's Tine Porinta. He is a senior expert data science, predictive analytics and modeling in Lake Novartis. He is going to present machine learning and data mining of bioprocess data using Orange. Tine, the stage is yours.
Hi, hi. I will present the work done with the Faculty of Computer Science, Blaž Župan and Novartis. And presentation will be done in Pecha Kucha style because it's only 3 minutes, so let's start. Orange is an open source, cross-platform data analytics suite. It features a unique combination of data visualization facilities and machine learning capability. And it's exceptional in its user-friendliness and boasts a huge set of data analysis components. Orange features visualizations, workflows, and a large array of specialized components for data analysis. Workflows are designed and executed through visual programming. All visualization in Orange are fully interactive, end-to-end. Orange is packed with components for machine learning and explainable artificial intelligence. one can easily cross-validate the different predictive modeling techniques, and one can further compare and analyze their precisions and accuracy. As mentioned in orange, the workflows are highly interactive. A change in any of working components immediately propagates to the downstream components. In this particular example, selecting a subset of misqualified data in the confusion matrix highlights this subset in subsequent visualization. By combining data components for data visualizations and machine learning, we can characterize the identified clusters of data, and we can then proceed to find distinguished features either through feature ranking or development of more advanced predictive models. Orange has been regularly used within Novartis to analyze and design the bioprocesses, which we use to develop and produce our biologics. Here, historical processes are collected in a central database and analyzed in Orange to enable quick, data-driven decisions during scientific meetings. For more detailed insights, we can easily construct a complex workflows, including advanced algorithms such as random forests, neural networks, and AdaBoost. We often use such workflows to dig deep into our data and optimize our processes or find a potential root cause for challenges we are facing. For example, we are using Orange to predict the outcome of expensive bioprocess quality parameters by looking at cheaper and faster surrogates and building predictive models. Thereby, we are not only reducing the cost, but we are also decreasing the lead time to obtain these valuable results. With 1 million lines of code, Orange is the largest and the oldest free Python-based program toolbox. It is used by several thousand people every day. In collaboration with Orange developers and the affiliated company Revelo, Novartis path is workshops, trainings, online help, and machine learning of bioprocesses. As Blaž would say, we are democratizing data mining in Novartis. So let's the questions begin.
Thank you, Tine. Interesting. Yeah, that's a insight into how a tool works and how you can help yourself with it. I would have a question. How long does your analysis usually take?
Actually, what we can do, we have various types of this analysis. One, they are very important and they are some kind of really quick. We can give the decisions and some quick data mining during the meetings. Let's say the question arises inside the meeting and we can answer it instantly. For more complex ones, which are usually root causes or some kind of really complex analysis, there are days, weeks, or even later. So it really depends. But what it is really important that you can make a quick data-driven decisions on the one hand, and also a complex analysis on the other hand, if necessary.
How did you decide for Orange? What was the criteria?
Yeah, we started, let's say, quite long ago, in I think 13 or 14, and one really, it was that they are local, they are really close. So when we have some our specifics, desires, we can contact Blaž, we can contact University of Computer Science, and they made widgets only for us because we have some kind of special desires how to analyze bioprocesses, and there are specific tools that are developed for our challenges we face in industry. So this is really good that we have a close collaboration and we are also geographically close.
That helps a lot. Local support, listening to your needs, adapting to your needs, that absolutely helps a lot to have a successful project. When did you start collaborating?
Yeah, we started, as I said, I think in 14, let's say 6 years ago, I think, or maybe Blaž can be more specific, but I think it was 6 or 7 years ago. So it takes some time to develop, to also, how can I say, to speak the same language. I think it takes 1 or 2 years just that you are on the same level, that you start speaking the same language.
To align the understanding on both sides. Absolutely,
Exactly.
absolutely agree. Thank you. Very interesting case of a nice collaboration of academia and industry. Thank you, Tine. Maybe we'll also get back to you later. But again, I would like to welcome everyone who joined later. This is Unimind's event. It's Smart Future. We are in the data science and business intelligence track. And I would like now to introduce Aleš Zamuda. He's an associate professor, University of Maribor. Aleš is going to present us something, please get ready. Business intelligence through computational intelligence for data science, an overview of the breadth of real numerical optimization solutions through autonomous submarines, forest modeling, power plant management, space probes, protein modeling, radio signal coding to text summarization. Sounds very interesting. Aleš, the stage is yours.
Thank you very much. So here is a few of my slides in 3 minutes. Let's try to explain these things. So what I want to tell you about is a few of my recent benchmarks that I did, my researches. One of them, for example, is, as you mentioned, text summarization. And I summarized some texts, interesting texts. I can explain maybe later. And also I've been tackling challenges in underwater submarines and how to navigate these submarines. The same thing, if you can imagine, among both of these challenges are optimization algorithms. And these optimization algorithms, as they are part of computational intelligence, what they can do is they can learn about the challenge of the benchmark and solve it without giving it explicit results and how to solve this. For example, we designed just scenarios for this and didn't tell the tool how to solve it, but then it was able to solve it. Also, I've been working with the modeling of different ecosystems. So here I also then use these algorithms that were able to reconstruct the geometry, the morphology of the trees. And this morphology, when done, it was able to grow. So I was reconstructing three-dimensional scene.
Sorry, Aleš,
usually what we can
are you
see
sharing your screen? Aleš, sorry, are you sharing your screen?
Yes.
We don't
sorry.
see your screen. Yeah.
Can you see now?
Yeah, now we can see it. Yes, yes.
Yeah, thank you. So here is the summarization. Here is the gliders. Here is the algorithms. I didn't show too much. I just have three simple slides. And there were some more challenges like the ecosystems and the scheduling of energy and some more. There are many papers describing this, so technical, explaining everything in 3 minutes. I will just do a survey, and then if someone is interested, I can say more. So here are some more business intelligence highlighted papers. Again, text summarization, I did a lot in high performance computer modeling and architectures, published some things there. Also were helping in this supercomputer story we hear about from our Slovenian supercomputer story. And the most recent thing is, since I have only 10 more seconds, a Daphne supercomputer industrial leadership project, and I have many other more projects, but I can tell them maybe in the later. Thank you.
Mm-hmm. Thank you, Aleš. That was really quick. Thank you. I would like to ask you maybe if you could tell us what are your favorite top 3 projects, which you really like and really relate to the data science and business intelligence.
Yes, thank you. So the first one would be this text summarization, which is the biggest artificial intelligence challenge since quite a while. All the benchmarks in this text summarization are still not performing well. We have many specialized computational intelligence, or some call it artificial intelligence, but artificial intelligence also the ants can do so. If we relate to people that can program, we go to computational and computer intelligence. So in this part, the computational intelligence is still weak in text summarization. This is one of the weakest, although we have this GPT-3 from AI, but still is very, very poor. Then I like to combine this with high performance computing, and I then can highlight this Daphne, which will start now in December, be very nice H2020 project. And another is this our supercomputer project. I went into these projects through, as you can see on these videos, I've been modeling.
Could you share your screen? Sorry to interrupt. Could you share your screen a little bit? The videos we can't see.
Sorry, can you repeat?
If you can share your screen, we don't see the videos. It's not shared.
The screen you cannot see?
Nope.
The videos. It should be visible.
Now it's gonna be
Yes.
The videos on the right.
Yes, on the right, just small. Because we don't have so much time. I have put them also on YouTube, and there is more of these videos. But since we have a limited time, maybe what I can also show is a bit of these gliders. This is one also interesting project. I do underwater glider modeling and navigation. For example, I started in 2011. These were some challenges in space probes, how to get to Saturn, and these Cassini missions and these things. But undersea things are much more difficult because we don't have so much communication lines underwater. So what we do is we model the undersea currents and optimize the path. And we have very unknown environments here. And I published some of the publications, and I could tell a lot more. I have 500 slides for you if you want, but not possible today. Thank you.
Thank you very much. Very interesting, very broad. I'm sure there are companies who could use that knowledge for sure. Thank you very much. We can get back later. So I would like now to introduce Matjaž Hriberšek. Matjaž Hriberšek is full professor, University of Maribor, Faculty of Mechanical Engineering. Also, Matjaž's title is a little bit longer as well. It's development and practical application of a computer model for predicting the working range of devices for performing the process of sublimation drying of active pharmaceutical ingredients, right? A bit longer, but I'm sure you can explain it nicely.
I will try.
Thank you.
Thank you very much for your introduction. I hope we can see the presentation now, hopefully.
Yep.
Very well. So this is a short report of our research and development work put together with some of the companies in Slovenia and also in the some foreign countries. You can see here the research team that is also behind all this work that I will shortly present. It's always teamwork. There's no way to nowadays to be a lone rider, so to say. So well, nowadays development of processes in advanced engineering practice requires the use of modern computational tools. And these are mostly based on mathematical models, which can be mechanistic or statistical. And I will present both cases today so that you will see the differences between them. Of course, you need also data from real processes. You need process analytical techniques that enable you to see what's happening in certain parts, let's say, of a certain device, and which can be later used for validation of developed models. And when you have a high resolution model, let's say the 4D model, 3D for space and 1D for time, then you are able to really produce some optimization to carry on optimization of devices, machines, processes, and at the end also to be able to have relatively simplified models developed from these complex ones, which are then used for real-time control of devices. So let us now look at the first example. It's an example from pharmaceutical engineering. It was done in collaboration with Novartis. We presented a more detailed description of this process in last week's Novartis Researchers' Day session. But here you can see that this is a classical example of a mechanistic model where you have underlying physical processes like fluid flow, heat and mass transfer, which are then cast into partial differential equations, which need to be solved in a numerical way. And this numerical solution is always performed on computers. When you validate such models, then you have a reliable computational tool, which enables you to really have a detailed, in-depth look into the physical processes inside the device. And in this case, with freeze drying, which is the other explanation of lyophilization, we were focused mainly on what's happening inside a vial. Vial is a small glass container which holds a significant amount of, let's say, fluid, which has to be dried. And of course, if you have a computational tool that enables you to determine temperatures, humidities, and several other parameters, then you are able to optimize the whole device, the whole process. Optimize in a way that you have the best quality product in the shortest possible time with as little energy consumed as possible. The other case is a case from, let's say, modeling based on statistical data. And this is a case of natural gas consumption modeling. You know, on a state system level, like in Slovenia, in Croatia, we have to somehow be able to predict the quantity of natural gas that will be consumed in the next few days. It's very important for the system providers as well as distributors that need to assign certain quantities that they will distribute or buy. And it's also important that all the parties that participate in this market have the same computational tools for prediction of these quantities. So we did some development and research work for our energy regulatory agency and also for Croatia regulatory agency, where we developed models for natural gas consumption. And these models were done in two different ways. One is quite simple data approximation model, which is basically producing approximation curve that reasonably well approximates your set of data on gas consumption. And the other case was developing neural network and determining the parameters of this network by genetic optimization algorithms. And of course, when you develop these models, it's always, you have to then distinguish between the learning phase, the development phase, and then the phase of using. And the learning phase, the development phase always takes more or less more significantly more time than the application. The application of these statistical models is then quite, let's say, straightforward. And you can develop several different models that are tailored to certain types of consumers. So let's say that providers and sellers of natural gas can then adapt their buying strategies accordingly. So this was now all that I wanted to say. This short two snapshots showed our research and development work. And of course, we have much more to show, but in short time, I think this was quite enough for start of the debate, possibly.
Excellent. Thank you. Very interesting presentation. I would immediately like to ask one question, just to get a feel. What is a typical computational time demand for both of these projects? Let's say freeze drying and the gas consumption.
Well, in case of, let's say, start with the second one, the learning process of these statistical models is basically few hours to one night on a desktop, let's say, workstation. But when we come to the development of 4D model for describing the total physics inside the, let's say, large freeze drying unit that holds 10,000 of vials, then its computing time goes into, let's say, 1 or 2 weeks. But of course, also the process takes 48 hours in real time. So it's not that bad, you know.
What platform do you use? Which computers do you use for that?
We use, let's say, for development, fast development, then we use, of course, capable workstations with several cores, of course. But then for computing, we use clusters of computers, let's say, typically 10 to 50 processes, cores. Also for larger ones, also we have now in Maribor one small supercomputer and one larger at in Wake, so to say. And we also use these platforms, of course.
I'm sure, I mean, these scenarios are completely fit that you use these supercomputers.
Yeah.
Tailored to use this. So at least they are used in some useful way. Excellent.
Yeah.
Super. Thank you, Matthias. Very interesting presentation. And we will get back later if we have time for any questions from the audience. Thank you very much.
Yeah.
And I would like now to introduce Igor Perko, Associate Professor, University of Maribor, Faculty of Economics and Business. And Igor's presentation title is Current Constraints, Trends, and Development Opportunities in Business Intelligence and Forecasting Analytics. Igor, the stage is yours.
Thank you. Can you hear me? Can you hear me? Perfect.
Yes.
Okay. Now, I actually come from the University of Maribor and Faculty of Economics and Business, which is a bit different. And that means that the perspectives are a bit different as well. Okay, can you see the screen?
Yes.
Yeah. Now, what we have been discussing by now are actually a very, very sophisticated projects that go well into the future. So basically creating prototypes, at least from the company's perspectives, that produces quite some stress in the organizational sense. So I would like to discuss a little bit about the difference between the business perspective of business intelligence and the developer's perspective of business intelligence, which is, let's say, it's not really the same. Okay, I'll try to do something. Yeah. So, basically, we have two constraints. One is the constraints in development, which we were all facing, and those are technical ones. And those are limited with technological capabilities. And I'm really happy to see that advance is going, that development and research is going really forward in that, invoking artificial intelligence, some agents, new modeling techniques. And this creates a kind of disruptive technology. But on the other side, we are facing organizational capacity to actually observe, use those new gadgets, and we kind of get stuck here. In some cases, these new technologies are used for specialized employees of the company to provide some kind of simulations, and it ends there. And if we go 3 steps back, even the regular technologies like OLAP are still not being used in companies. So I think we could focus a lot on the organizational capacity. And if we are using technological capabilities for the really complex problems on one side, right? You know, those the implementations of those technologies in the company gets to be complicated as well. And you know, when Jure Leskowitz says, okay, we go forward and leave the implementation to the technical stuff, well, I think it would be very interesting to go more with people who say, well, let's use anthropologists to see if there is a complexity on the other stuff. So we don't have only one complexity, the complexity of the problem, but we have 2 complexities: complexity of the problem and complexity of the user trying to use that. And you know, those users have really limited capacity to use these new technological capabilities. I'm sorry to go into the jargon like that, but yeah. Now, you know, when I was trying to look at the trends, where are we going? We are still dealing with the old issues we had several years ago, and that is basically data management, quality data management. That is something that is you know, you do that in when you design a prototype. Really invest like 80% of the, or even 90% of the time in clearing out the data. But if you want to pull that to the business side, to use it in a day-to-day operations, we have a problem there, because the data quality is still not resolved. And this is why people are investing so much effort in really achieving the data quality issues, right? And additionally to that, we are dealing with ignoring data on all levels, you know, and you know, there are, you know, organizations are trying to use the top-down approach. So basically, go from top, use some business intelligence there, and try to spread it down. Now, this usually does not really works well, because on the operational level, people don't really understand the issues they have on the top level. And in this case, business intelligence usually does not work well. You know, the trend is to really support the collaboration of people, because nobody has the capacity to deal with the issues presented alone. So creating teams and doing that not for the existing product, but for the new product developments. Those are actually the trends that are from outside. And now let's go to the opportunities. And we actually have 2 sets of opportunities. We have the implementation opportunities and research and design opportunities. And in implementation, now we really need to focus on understanding the needs. And it is very interesting that the needs of the users are quite different to the problem we are trying to solve in the first place. So again, we have 2 complexity: the complexity of the observed problem and complexity of the user that has to deal with that. And if you want to really make business intelligence and business predictions and even prescriptions valid for the end user, we need to think about understanding the needs of the end user, the business user. And we should support the processes they are daily working on. especially on the operations level, not on the strategic level or the high level, but really on the operations level. And this is, again, will get us to a new set of issues we should deal with seriously. And on the research and design team, it's to be reliable, available, situation aware, supportive. And yeah, this is the things we are trying to do in the Faculty of Economics and Business. So not only technology, the other side should be important and is important as well. Yeah, I think my 3 minutes are off. So thank you for listening, and yeah, I'm here to answer some questions.
Thank you very much, Igor. Also from the other angle, to see the data science area, business intelligence, thank you very much. There is a question, for example, should we focus on research or on development or implementation? What would you suggest?
All of the above. The idea is, yeah, well, you know, when you go to examine a problem, you really go deep and try to figure out what it is all about. So that's the research part. But in a certain, you know, you need to have a plan of how to use that. Not just go to the research, but already have in mind that when you go to the research, you will have another step, which is examining and do the same research for how to employ that. And in which situation, in which cases, is it to be on the operational level, for instance, fraud detection, yep, or is it to be on the strategic level, for instance, prediction of profit of a company? But we should not stay on the you know, and we can use the same methods for both of them. So really research the case problem is imperative.
Okay. Thank you, Igor. Thank you. We can get back later if there are any questions. Thank you again. For the participants who joined later, this is Unimind's event, Smart Future, the Data Science and Business Intelligence track. And I would like now to introduce Tom Vodopivets. He's a Director of Data Insights with Celtra. Tom Vodopivets is going to present when and how to outsource AI. Very interesting topic. Tom, the stage is yours.
Thank you. Thank you very much for the introduction. I think you can see my screen, right? So very interesting talks up so far, and the perspective from the research institutions, from the academia. So now I'm going to give a perspective from the other end of the line, from a company, right? So I come from Celtra. We are developing software for advertising technology, and I'm the director of the Data Insights department, which is primarily tasked with business intelligence. So we do data science, we do data analytics, we do data mining, but the whole purpose is to do business intelligence to guide the decisioning within the company. And we have quite some experience in the recent years in cooperation, especially with the university, Faculty of Computer Science in Ljubljana, about outsourcing, but also with other companies, outsourcing artificial intelligence, or let's say data science in the broader aspect, okay? So first of all, when not to outsource, or let's say what not to outsource, okay? Wherever you have we had some business decisioning, this is usually requires a lot of context, a lot of overhead in transferring the business knowledge. Igor just mentioning, understanding the needs, that is a big problem for someone who's not close to the industry, right? The other no-go is production. So outsourcing development of production-ready system, production code. This is the turnaround is just too slow for production-ready, right? So in general, the rule of thumb is don't outsource there where it hurts if you fail. So don't outsource where the failure or the experiment is expensive. On the other end, when to outsource then? Definitely a lot of benefits can be gained for prototyping, exploring, so proving your concepts, shooting off, bouncing off your ideas. If the technology is capable, if the newest state-of-the-art methods are capable of producing for you new products, right? So new products either for your clients or either new products in terms of internal tools to optimize business, to optimize decisioning. So again, as a rule of thumb, do outsource those projects where failure is acceptable. There is a high research, high risk, and high failure, and if that is acceptable, go for it. And go for it. Why? The benefits of doing this is, so I can tell from exactly my own experience, we running through the business 100 an hour, we can get detached from the state-of-the-art research, from the state-of-the-art technology, because we don't have time to look around. Doing these projects with the universities, with students, with academia, with research institutions, helps us keep in touch with the state-of-the-art, research, with what are the boundaries, what's feasible to create, right? From this state-of-the-art, we can get new ideas in-house, or new ideas come to us through cooperations. And one of the major points of cooperations for us, we spot great talent. We work with great talent, we work with great people, and we can continue these cooperations further on. So if we defined what to update, what to outsource and what not, the question is how to outsource. Okay, we found out it works really nicely if these are closed, smaller projects like one semester projects. I think Eric Strumbel in two presentations from now will talk about the Master Science study in Ljubljana, and this is also a great example of our cooperation. He will tell more later. So the one semester projects work really nicely and much better than, let's say, final thesis, bachelor thesis, master's thesis, PhD thesis, because it allows for a short turnaround. The project should have clear scope, very clearly defined goals, very clear context, and they shouldn't require micromanagement. If there is a project or a task that requires micromanagement, it's likely not suitable to outsource. And whenever you outsource, the main point that is, I would say, might be forgotten, there should be always mutual benefit. There should be a benefit for the researchers, there should be a benefit for the university, there should be a benefit for the company. A way to provide benefits, if short-term are not visible, engage in a long-term story. Okay, long-term story could be, for example, once the students or the researchers finish with a project, you can engage them in like internships or other projects that you have in pipeline. Here are some of the examples that we did in the last year, with universities. So you can see ranging from outlier detection and deep neural networks up to pure, let's say, AI methods, AI algorithms, decisioning algorithms, search space algorithms like bandit algorithms. And thank you for listening. I'm open to questions.
This is excellent presentation, short and to the point. This should be heard by a lot of people, definitely. I especially like the prototyping to be outsourced. This is the excellent example how to use the talent outside of the company. For prototyping, many things can come out of that, for sure. My question to you would be, how can university research convince more companies to outsource AI? What would you say? What would you recommend?
Yeah, I think this point has been raised by a couple of presenters already before. I will again emphasize here Igor just before me, who said understand the needs, right? Understand the needs. I know that the university, the researchers are, let's say, further away from business, from the economical trends, right? But you are acting as competition to existing companies out there who are also providing research capabilities, right? Research capability, research solutions. So I think the university should think more entrepreneurial. So think about how to analyze business needs. Think how to understand the companies better. You need dedicated personnel to do this. You can't have a state-of-the-art researcher who specializes in something else, So, you should be a business consultant for a company who doesn't know how to employ artificial intelligence. Go in there, send a dedicated translator. We heard that the translator, right? Exactly. This is
we'll still hear this in the next presentation, I'm sure. Translator is the occupation of the future, for sure.
Yeah. So I would say the university should start heavily employing actually translators. They are those who bring most of the value to both sides.
This is music to my ears, definitely. Translators, this is the message we also wanted to share, that there's not only data scientists, but it's also something in between, which understand business, understand the AI benefits, values, and so on. So yeah, definitely very nice presentation. Thank you very much, Tom. For sure, we'll come back to you and have some questions later if there will be time. But now we have to rush a little bit. We have now, I would like to introduce Franz Bracciun. He's a Chief Data Officer at NLB. Franz is going to present success factors in introducing data science and business intelligence into an organization. Franz, the stage is yours.
Mitya, thank you. I would like to share our experience in NLB, our experience about introducing artificial intelligence or machine learning solutions in real business. We started our journey approximately 4 years ago, and at that time there was very little information about artificial intelligence in the news. But today, as you probably know, there is a lot of fuss about artificial intelligence. We can see a lot of news about how and what is possible to do with artificial intelligence. But our learning, or what we found out, is that what is more important is what is behind the screen. Actually, what I'm referring to is how companies are capable to build such kind of solutions. And actually, when we started, we immediately know that we have to build internal capabilities in cooperation with external companies, capabilities that will help us to be able to build, develop, and introduce these new solutions which are based on machine learning and deep learning technologies. And when we started with technological part and with data science parts, meaning that we started with putting our data in good shape, meaning we renovated our data warehouse and implemented data management platforms, which helped us to integrate data from different sources. We also introduced a platform for building, developing, and deploying machine learning algorithms in production. And of course, we also established data governance as very important topics, because information or data, it has to be governed properly to be useful for the company. But during this journey, we recognized that in the later phases, what is very important for us is also to tackle this more soft capabilities, meaning people. And of course, we found out that we can have whatever, let's say, technology is possible in the world. We can hire external consultants. We can, let's say, bring new data sources, etc. But if we don't have our internal people capable with proper skills to use such kind of solutions and to maintain such kind of solutions, we cannot be sustainable on the long term. Therefore, we immediately started also in the last year and in this year in particular to prepare our training program to reskill our internal personnel to be capable to use, not only to develop, but also to use new technologies in their regular daily business. So we introduced 3 different rules, or 3 different jobs that are very important in this environment for us. two more traditional introduced several years ago. One is data engineer. These are our colleagues who are responsible for data management. Then we have machine learning engineers. These are our colleagues who are capable for developing machine learning models, statistical models, etc. But very important rule or job that we introduced this year, we defined and introduced this year, is actually analytics translator. This rule is actually some kind of bridge between our business people and our specialists who are capable to build machine learning and statistical learning models. These people are responsible for identifying what are the opportunities to introduce these new solutions in regular business. So what benefits we can expect as an organization from this new technologies. Then, of course, what is very important, there could be several opportunities. We should prioritize them properly. Therefore, it is very important to prepare proper business case, and this is not easy task to do. Preparing business case for artificial intelligence or machine learning solution is quite tricky. It's not simple. And of course, these people are also then responsible to define the requests for people who are able to build such kind of solutions. And they are in the position to be some kind of bridge between business people and our more technical people. And during this cooperation between business and technical people, of course, there is a lot of cooperation when we are developing these models or solutions. But one very important phase and usually neglected very much is how to introduce this solution in a regular business. And here the rule of analytics translator or data translator, as we call it in our bank, is very important, because this job or this rule is responsible to monitor and to guarantee that business processes are prepared properly to introduce such kind of solution, because there is a lot of tasks or a lot of activities that have to be done before we can introduce a new solution. For example, just one example, let's say we introduce a machine learning solution which influences the decision in the business. So there is probably some necessity to change the rules, who is able to decide about what. So, and also these people are also responsible, this data translators are also responsible to care about and to monitor that people are properly trained to be able to use the solutions as effectively and efficiently as possible. That's our journey where we are now, and I'm open to questions.
Mm-hmm. Thank you, Franz. Very interesting from the field, I would say, from the trenches, some insights. We have one question from the audience. The question is, what is the profile of a data translator in terms of education and experience?
Well, actually, this data translator, he has to have a deep domain expertise from the business perspective. He has to understand different machine learning models and how they can help business to do business better. It is not important that they are capable to build such kind of models, but it is important to understand what these models can bring to the business. And these people are also responsible to help, let's say, redesign the business processes to be prepared to introduce this artificial intelligence solutions. And this kind of people are some, let's say, some intersection between, let's say, economics, social scientists, computer science, organizational science. So it is some kind of mixture. And actually, we as a bank found out that this is the most crucial rule. And this is the rule that is most scarce in the market. It is very hard to find such kind of people. Therefore, we prepared our internal training with cooperation with external provider, and we will have to retrain our people which will be in this role. But of course, in addition to that, we are also hiring. Right now, we are in quite deep hiring process for this kind of profiles to bring us a new knowledge.
Thank you. I have a few questions also, but maybe we can get back to them later. Maybe just one here. If you can explain a little bit, what were the failures you learned from? What was one such failure you can remember and you learned from it?
Well, actually, I think that the most important point is at the beginning. At the beginning of such kind of project, you should be very careful to define what is the goal of the project. Because if you do not define this goal properly, at the end of the project, there will be mismatch between what was expected and what was delivered. And actually here, the role of this data translator is crucial because he's responsible to translate business requirements into the, let's say, data science requests. And he is the one who has to align these two sides to understand each other properly. So from my experience, this is the most crucial point, because if you fail at the start, you will never finish as a winner.
Thank you, Franz. Very interesting presentation. We can get back later for some questions. Thanks again. And I would like now to introduce the next speaker, is the last one. So we were coming to the end. This time we have Erik Strumbel. Erik is a senior research associate, University of Ljubljana, Faculty of Computer and Information Science. Erik is going to tell us about integrating companies in data science master's study program. Erik, the stage is yours.
Thank you for the introduction. Can you hear me and see the slides?
Yep, yeah, we can hear you.
Okay, great. Okay, so hi to everyone, and thanks to the organizers for inviting me to give this short talk. To be brief, about 3 years ago, we started thinking about producing a new data science master's at the Faculty of Computer Science here at the University of Ljubljana. It started in 2019, and now 3 years later, we have our first generation of students in the second year, and we've enrolled the second generation of students in the first year. So one of the things that stands out about this master's is that very early on, we decided that we want to integrate collaboration with industry into the master's. So today I'm going to talk about 3 things. So why did we decide to do this? How did we do it? And some of the lessons learned so far. So why did we decide to do it? There are 2 main reasons. So one of them is that in order for our students to get a really complete education in this field, it's necessary that they also have some exposure to real world problems. Okay, and that's only possible if you collaborate with industry. And the second reason is, to put it bluntly, to get financial support. So our goal is not to just be a data science program. We want to be the data science program, at least in this region. And in order to attract good students, to attract good invited lecturers from abroad, to provide new quality content to students, you just need financial support. And within the university framework, you're typically operating with a 0 budget. So there is no other way than to get financial support from industry. Okay, so those are the main reasons. So how did we decide to do it? So there are 3 main points of integration of industry with our master's program. It starts with the Introduction to Data Science course in the first semester. Every week of this course, we invite experts from our industry partners and from other companies and from outside of academia to talk about different topics, from managing data science projects to industrial problems, to IP management, to legal privacy issues. So companies have an opportunity to meet the students. Students get to are exposed to real world problems, and we all learn new stuff every year, especially some stuff that's difficult to keep track of if you're in academia because it changes so rapidly. The second point, and probably the most important one, are projects. So in the second semester, students work in teams on real world problems from industry. For example, this year they worked on everything from ad prediction, click-through rate prediction, text mining of legal documents, tracking basketball players, and so forth, and smart cities. So it was really a success this year. And like Tom from Celtra, who is one of our supporters, mentioned, it's a very good opportunity because they are short, low-risk projects, and maybe they evolve into something more, maybe they don't, but it's a short turnaround, and it's a very good experience for everyone involved. And then in the third year, we have a substantial part is dedicated to the master's thesis, and students up to that point will have been exposed to real-world problems, a lot of them, and often they will choose one of them for their master's thesis. So in the future, we also plan on having at least some elective courses driven by problems from industry. So once we identify a suitable partner, we might even form an elective course on a particular topic that's hot at that point in time. Okay, and then maybe some of the lessons learned. I've kind of 3 things that I would like to point out here. One is that this kind of bottom-up approach from scratch really exceeded my expectations. It seems to be a really good, low-cost, low-risk investment for companies, also a good opportunity for everyone to meet each other. And then if things evolve, and it seems that at least some of them will evolve to more substantive collaboration, that's great. And if they remain at that level, that's also good. But we can already see the knowledge flow from academia to industry and from industry to academia, also human resource flow, and eventually I think also very good substantive projects. Second thing is it does take some time and effort. And I think the biggest bottleneck right now is that it's not even the data science field, but also not collaboration with industry is as mature as it can be. So as people from industry learn more about collaborating with academia, and academia learns more about how industry works, things will only get better. And final and probably most important thing is that a kind of a cookie cutter approach to this type of systematic collaboration does not really work. So every company is different. Not all companies are suitable for this kind of collaboration, and even those that are, every company is different. There are different needs, and often those needs change. So the most important thing that I learned is that you need to listen and be adaptive. So I'll conclude with that. Thank you for your attention.
Thank you very much, Eric. That was quick and informative. I would have a question here regarding the program. What is your plan to attract more companies to support that program?
So what is our plan for?
Yeah.
Well, currently, things really exceeded our expectations. We can only take on so many companies. Okay, so we have sort of a limit. We can't really have 100 companies and 20 students. So there is a limit, and we're actually very close to that limit. And first wave was through people we knew. Okay, so you have some existing collaborations, and just with that, we managed to get, let's say, 4, 5, 6 sponsors. Yeah, we're now at maybe there's. Actually, I would say a lot of interest, and we only probably will take at this point maybe 10. So from all the things, I think that's the least of our concerns. It seems like if you asked enough companies, you will have enough sponsors. So that was kind of a surprise, but a lot of people didn't expect that. But there are a lot of very good companies and interested companies in Slovenia, and I was really positively surprised by that. So
I'm glad to hear that. This is something which we are looking forward, that you generate more data scientists, especially also with this in mind, to have business translators or analytics translators as well, to touch this area as well. But this is something we need to look forward to. I work for a company, CreaPro, and of course we are also looking for talents. And I would like that, you generate, quicker. You generate good talents quicker. That would be marvelous.
Yeah. So that's the main goal. I mean, provide good people, not just for industry, but also for ourselves. Yeah, so we need to think for the future. We need who is going to lecture this stuff in 10 years. So that's what we're building.
Exactly. Yeah. Thank you very much, Eric.
Thank you.
Great presentation. It fits into this whole picture here. I would like now to thank everyone for your participation, for your presentations, and I would like to invite you maybe to ask questions to other presenters. I'm sure there are some questions. It was very interesting. The topics are very interesting. So if there are any other questions, please just speak, and we need to know, maybe we need to open a debate. From my side, I would like to ask Franz Brăciun, who is representing banking world. I would like to ask Franz, how does he see the role of AI in banking in the future?
Well, I personally believe, and I'm quite confident that, let's say, in the 5 years time frame, actually we will not talk about AI anymore, because AI will be embedded almost in all banking products. Not all, but almost all of them. It will be very similar of today's situation. When we are using our smartphones, we are not aware that all the smart applications are actually AI capable or supported. And a similar future I see in the banking. So in each banking products, there will be AI embedded and working behind the scene to enable users to use this banking services more efficiently.
While we are on this topic, can you quantify what are the effects of implementing AI in the bank, in your bank?
Well, actually, yes, I can. I have figures, but of course, I cannot dispose them. But I can give you an example. For example, we introduced this year one solution in our, let's say, offers to our customers. And this solution, or this, let's say, machine learning model, helps us to increase market share in one segment, business segment. So the results are very tangible, and we can show them in the real money. So proper usage of AI solutions can bring money, a lot of money. But the very important point is proper usage. Not usage, because at the end of the day, if we have models, they are bringing costs if they are not properly used.
Damage, even damage can, yeah. I agree on that. Please, any other questions?
Maybe a question for Tom and Franz. Yeah. We are always implementing some kind of prototypes. What about a long-term use on the operational level? You know, adjustments, standard monitoring. You know, it's operational. This is costly.
Yeah.
Right.
I can give you an example. In our bank, in banking industry, we are very regulated business. So we have our regulators monitoring us all the time. And we have to be able and capable to explain our regulators how are our models behaving in real life. So we have to monitor this model, to validate this model, and that brings costs. And of course, using this model in production, they are not working there and you can leave them to work. You have to monitor them, and to immediately, when you find out that they are some kind in misbehavior regime of working, mode of working, you have to act properly. So actually there is not end of story when you introduce this model, because this model lives and you have to monitor them and manage them properly.
Yeah, I would add to that, monitoring the monitors, right? So, right, what are we experiencing is concept drift, right? You set up some monitoring system of your operations, of your business indicators, of KPIs, right? But these KPIs change. The interpretation of these KPIs change. The underlying data changes, right? So developing is just the beginning of using something, right? So, right, so I would say, I can speak for our experience. It's required too much of business knowledge, context knowledge, domain knowledge that somebody out of our company could build these systems, but they can provide us the tools to do so, right? We need to shape the problem that needs to be tracked, monitored. We understand the operations, we understand the KPIs, we keep them aligned with the concept drift, right? But we can get help in terms of external specialists for some, I don't know, outlier detection, right? Or by the book, business intelligence tooling. There is a myriad of companies out there offering BI tools, right? To put this up, right? So that would be my answer, right? So the content comes from within the company, from the business specialists, right? The tools and the technological solutions can come from outside.
Excellent.
I totally agree with that.
Thank you, guys.
Can I ask one question? I know that we are already out of the
out of time.
Of time, but I would just like one small question, also for Franz and also maybe for others coming from companies. If you are familiar, or do you know that in your companies, AI is used for recruitment selection processes and recruitment processes? This is something that I'm now a little bit involved more deeply in, and biases produced and so on in those processes. So I'm interested if someone has done this step forward. I know that sometimes this is difficult to admit to the public, but I'm interested in whether, or if you are thinking about it, introducing this.
Well, we are thinking about it. We didn't implement it yet. One very important bottleneck or obstacle is GDPR, because you need consent from the end user, and it is very hard to get consent from applicants for the job. So it is very tricky. So I think that here we have, let's say, more, legal challenges than technical challenges, how to do this. But we are thinking about, but we didn't have it yet.
Yeah, here also there will be need for a lot of monitoring, or let's say auditing behind the entire process. Yeah.
Maybe just to explain the audience, if they don't know what GDPR is, it is actually the legislation relating to personal data protection, which is very strict and quite challenging.
Maybe a word to Ida. I think researchers should cope with that, but also not just cope with the technical perspective, but also with the ethical perspective of getting into privacy data, and maybe try to find a solution which would enable us to do something, but within the ethical borders we have. And I'm really happy to live in EU for that.
I would add this, if I may, 2 points on using AI, right? We use LinkedIn as a search tool, right? It has its own recommendation engine. So in that sense, yeah, we do use AI, right? It's built in LinkedIn, right? We search through Google, it does use AI, right? So we do use Google, right? To search for candidates. So we do use solutions that are out there, out of the box, that are heavily involved into AI and machine learning and all kind of recommendation and search optimizations, right? So this is one aspect of it, and we don't deal with GDPR in that sense. It's the companies who provide these solutions to deal with that, right? And provide a black box solution. On the other end, when we have the candidates in-house, right? What does it even mean, AI? Of course, we do data analytics. Of course, we look at budgets. Of course, we look at the projection of careers and analyze all that stuff? Do we translate that into data points? Maybe a sentence is a data point, right? Unstructured data, it is a data point. So the distinction now between doing AI and not AI is a linear regression on a candidate salary already AI? I don't think so, right? but you know, the boundaries here are getting fuzzy, you know, are getting quite fuzzy. And in our case, we do extensive analytics, right? But we don't do AI on the hiring process except for using what the tools already provide.
Mm-hmm. Yeah, definitely. I'm sure that at the end, there's always human behind taking a decision. And maybe in the cases where you have a lot of applicants, to narrow this huge input, you could use it. But at the end, it's always useful to have a human behind this final decision-making process. Thank you for your answers.
Yeah, any other questions maybe from any other participant? If not, I then need just to wrap up. Again, Unimind's Smart Future, the data science and business intelligence track. We had 10 speakers lined up. We successfully came to the end. Thank you very much to all of you. It was really interesting. There were interesting presentations, valuable input. And I would like now to hand over to Matjaž, back to Matjaž to take it over. Thanks again from my side and enjoy the day.
Thank you.
Thank you, Mitja, and all the speakers, and thank you all for joining us today. We can continue the discussion in Whova. There is a link in the chat box which will guide you on how to download the app. If you haven't done so already, you can find also QR code on the slide. We hope you enjoyed this event. Your opinion mattered to us, so please give us your feedback. Colleague Jana will paste the link in the chat box. Find more info about all Unimind's events and sessions on the event website. You can find the link in the chat box. Also, take care, keep an open mind, and see you at our next event. Bye, and I wish you a nice day.
Thank you. Bye.
Thank you.
Bye.
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 Bye-bye. Thanks.